Hi everyone. So in this video, I want to go through a few examples where we will be solving logarithmic equations. And so when I talk about logarithmic equations, what I mean is any equation that is involving a logarithm. So we might have a few logarithms, we're adding them together. We might have a single logarithm. But I want to illustrate how we can use all of our different properties of logarithms that we've built up in order to solve some equations that have them in them. So let's start with an example. If I have an equation that looks like this, say log of 2x equals 3. All right, so this is an equation that I may want to solve at some point, and we have a logarithm in it, and my goal is to figure out what x value would satisfy this equation. So essentially the log base 10 of 2 times what is equal to 3. Okay, so the first thing that we have to do here is we're always going to look around and try to get all of our logarithms together. And in this example, I have that. So on one side of the equation, I have a single logarithm, and on the other side of the equation, I have a number. And so it's important to remember this because we're going to see that in our future examples. This is the place that we always want to get to. One side of the equation has a logarithm, a single logarithm, and the other side of the equation has a number. Okay, so if we can get to this point, we're in really good shape. Okay, so right now, I'm going to put this little 10 here to remind us that log of 2x really means log base 10 of 2x is equal to 3. And so the first step that I'm going to take here is I'm going to use the snail, right? So the snail is the definition of the logarithm, and making the snail just helps us remember where everything goes. So I'm always going to start down here with my base. I'm going to start down here at 10, and I'm going to change the form of this equation. So instead of log base 10 of 2x equals 3, I'm asking 10 to the third power. So 10 to the third power is equal to 2x. Okay, so by using the snail, it allows me to rewrite my logarithmic equation as an exponential equation. And so what I have down here, 10 cubed equals 2x, this looks like something that I already have tools to solve. So the reason that I'm going to get a logarithm on one side and a number on the other is so that I can do this. I can use the snail and go to the exponential form, which I already know how to solve. So if we keep going here, it looks like I don't have too many more steps, but 10 cubed is going to be 1,000 is equal to 2x. And then what I can do is divide both sides of this by 2. And so I get, on the left-hand side, I get x. Or sorry, on the right-hand side, I get x. On the left-hand side, I get 500. So x equals 500. And if we wanted to go ahead and check this, right, so let's go ahead and quickly check and see what happens. So we'll do a quick check. Now, for logarithmic equations, I do like to check because if you recall, when we have a logarithm, we can't plug in negative numbers. So by checking our answers, we're just making sure that we don't have any of those false answers that are showing up because they're outside of our domain. All right, so what we have here, so log of 2 times 500 should be equal to 3. Right, so if we check, log 2 times 500 is 1,000. That's equal to 3. And we ask ourselves, is log base 10 of 1,000 equal to 3? The answer to this is yes, because 10 cubed is 1,000, right? So we've checked. This works out. Everything's in the domain. And I've solved my first logarithmic equation. So I'm going to pause this, we'll clean it up, and we'll come back with another example. Okay, so we are back and we have a new example here. So log base 2 of 6x minus 4, all of that minus 9, I want to be equal to negative 4. So in this example, it's not quite in the form that I want it to be. So what I would like to do is get a single logarithm on one side and all my numbers on the other side. And so if I look at this, I have this logarithm and I have this number, so it seems like if I take my first step, if I take this -9 and bring it over to the other side, then that's going to be okay for me, because then I'll have that form that I wanted. So in order to do that, I'm just going to add 9 to both sides of this equation. And so if I add 9, what I'm left with on the left is log base 2 of 6x minus 4 is equal to, well, -4 plus 9 is 5. Okay. So this is great. I have that form that I wanted. I have a single logarithm on one side, and I have a number over here on the other. And really what I would like to do is I need to get to this x. So at this point, in order to get to the x, I'm going to have to somehow undo this logarithm, and that's where we do the snail. All right, so I'm going to use the definition of the logarithm to sort of undo this with my exponential function and turn it into our exponential form. All right, so this 2 to the 5th power, 2 to the 5th power is going to be equal to 6x minus 4. All right, so we put our snail in there, and what this does is I now no longer have a logarithm. So I look down here at this equation. This is something that I know that I can solve. Okay, so let's go ahead and do that. 2 to the 5th is 32, is equal to 6 times x minus 4. Right, so what I'm going to do is I'm going to take this and we're going to keep going over here. Let's see. If I'm going to undo this, what I need to do is add 4 to both sides of this equation. Okay, so if I add 4 to both sides, what we get is 36 on one side of the equation, and we get 6x on the other side of the equation. Now what I need to do is divide both sides by 6, and my solution is x is equal to 6. Okay, so x is equal to 6. All right, so if you want, we can go ahead and check that this is a solution. So I'm a little bit out of space here, so I'm not going to do it for the video, but if you think about it, if we plug this back in, if we just do a quick mental check, by plugging 6 back into this equation, I'm going to get a positive number. So I'm going to end up with 32. So 32 is positive, it's in the domain of my logarithm, so I'm not going to really have any trouble there, and everything else should work out fine. All right, so this is another example of solving a logarithmic equation. Again, I'm going to clean it up. We'll come back, we'll do one more example for our video here. Okay, so here is our last example that we're going to walk through. I've got log base 3 of x plus log base 3 of 3x plus 5 is equal to 7. So this example is a little bit different than the others because notice I have 2 logarithms here now. So I have this log base 3 of x and I have this log base 3 of 3x. It's good because they have the same base, so I don't think I'm going to have to change any bases. Then I have this number plus 5 over here on the left, and I have just a number 7 over here on the right. So again, the first step that I'm going to think about is I want to clean this up, and I'm going to try to get one logarithm, a single logarithm on one side of the equation, and everything else on the other side of the equation. So this is nice because I already have 2 logarithms on the left. So step 1, what I'll do is I'll try to take this 5 and maybe bring it over to the other side. So in order to do that, I'm going to subtract 5 from both sides. And where we end up is we get log base 3 of x plus log base 3 of 3x is equal to 2. All right, so step 2 here, what I have to do is I have 2 logarithms on the left, and what I would like to do is make them one logarithm. So if I recall, if I'm adding 2 logarithms, so this plus sign in the middle is a big deal because it tells me that I can use my product rule for logarithms to turn this addition into a product of this x as the input and this 3x. So I'm going to use that rule, and what we get is on the left-hand side, we get log base 3, a single logarithm, and I'm going to multiply my inputs, x times 3x. Okay, so the rule for product says what I can do is take the addition of two logarithms with the same base and rewrite it as a single logarithm where I'm multiplying the two inputs together. And we get this is equal to 2. All right, so the first two steps I took here, I was looking towards the goal of one side of my equation has a single logarithm and the other side has everything else. Looks like I've achieved that goal, and so as we did before, what I can do is I'm going to do the snail, right? So I'm going to use the definition of logarithm to undo the logarithm here. So I have 3, right? So 3 squared is going to be equal to 3x squared. Okay, so let's write this down. So 3 squared, that's what I get here, right? So 3 squared is going to be equal to 3 times x squared. So that's what happens here. X times x gives me x squared, and then the 3 comes down here. All right, well, I think this is something that we can do. All right, so let's go ahead and continue our process here. And so this looks like 3 squared is 9, and that's going to be equal to 3 times x squared. All right, so for some more space, I'm going to take this over here. All right, so I'm going to divide both sides of this equation by 3, and on the left, 9 divided by 3 is 3, and on the right-hand side, I just get x squared. All right, so if I'm going to solve this, what I need to do is take the square root of both sides in order to undo the square. And anytime I take a square root, I'm going to have a plus or minus that goes along with it. So I get plus or minus the square root of 3 is equal to x. Right, so x is equal to plus or minus the square root of 3. Okay, so if we think about this for a second, one of these is not going to be an answer that I want. So one of these is not going to be in the domain of my function because I can't plug negative numbers into a logarithm. So I look here, I'm going to get the positive square root of 3 and the negative square root of 3. But if I come back up and check my equation, this is just an x here. So if I plug in the negative square root of 3, that's not going to work out because I'm going to have to take the logarithm of a negative number. And the same thing would happen here. I don't have that problem with the positive square root. So if we think about this, we don't have to go through the whole process of checking, but we see that this, right? So the negative part is not one of our solutions, and the only solution to this equation is x equals the positive square root of 3. Okay. So we walked through 3 examples of solving logarithmic equations. Now it's not going to encompass all of the different situations that you can see, but I think it should outline the process that we want to go through. Look at the logarithmic equation that you have and try to clean it up so that on one side you have a single logarithm and on the other side you have your number, and then using the definition of the logarithm, right, so using the snail like we did here, will allow us to get it to a place where we can get to those x's as the inputs and solve them using the different techniques that we know about. All right, so I hope these videos helped, and I'll see you next time.